No problem.
Okay, go ahead, Katie.
Okay, it's just on a self-assessment quiz. It's number 9. It says the compound A2X is 35.8% A by mass. What mass of the compound contains 55.1 grams of A? And my brain just goes blah.
Okay, can you say that again? It's A2X like I have up on the whiteboard.
Yep,
Okay. And then keep
yes.
going.
Is 35.8% A by mass.
X is 35% of A by
I don't think
mass? Like that?
it. No, it's saying A2X, like you have at the top there, and then it says after that is 35.8%.
Oh, 35%.
Yeah,
Yes.
35.8%. Yeah.
Okay, let me
And then it's worded really strange. I'm not a fan at all.
okay. Let me have a look at it.
Thank
Just
you.
because I'm visual.
Me too.
Okay, I'm just going to bring that up. Two shakes. Were you able to get outside today?
Yeah, I was out with my boys all day. It was good. It
Oh, lovely.
was really warm.
It's amazing how fast it changed to that. Like we just had snow a couple of weeks ago, and today, like my son was out in shorts because he's crazy, but
My husband too.
yeah. So I raked probably a couple hours today. I love it. I hope I'm gonna cry if it if it snows again, but you know that sometimes happens.
I refuse to look at the weather. It's be too damaging. I'm very happy right now.
Okay, I'm just bringing it up for myself so I can see, find it. Of course, it's not going to be question 9 because it changes everything around. Looking for A2X.
That's on. Let's see if I have the page written down. Page 190. That's self-assessment quiz.
Oh, sorry. A self Oh, sorry. Thank you. Question
No problem.
perfect. I was going over to a different spot. I was in the wrong space. Got it. Okay, the compound is 35.8% A by mass. What mass the compound? Oh, I get. Okay. Yes, I see. Let me just redo this. Yes, yes, yes. Okay. So we do have a compound A2X, and A2X is an unknown compound. We don't know what element is A, and we don't know what element is X. They're just saying two unknowns come together in the
Yeah.
ratio of 2 to 1 to form this compound. And 35.8% A by mass. So 35.8% of A2X mass is A. That's what they mean by that little the compound A2X is 35.8% A by mass, which
Mm-hmm.
means that 35.8% of its mass is A.
Oh,
I like it written like that a bit better.
me
And
too.
And then it says, what mass of the compound contains 55.1 grams of A? So they're saying that now, if we have 55.1 grams of A, what is the total mass of A2X altogether? So in this is a percentage problem, and what I like to do is I like to put it into into a sentence first, and then I flip it to math. So I'll show you what that looks like. It says that 35.8% of I know I already have it up there, but I'm going to change it a little bit, mass is A, right? So is 55.1 grams A. And then I'm going to take that sentence and I'm going to turn it into math. First of all, 35.8%, we have to change that to a decimal, and that's going to be 0.358. Are you okay with that, Katie?
Yeah, I was just trying to fix it up so I could see the whole whiteboard.
Oh, are you on a Mac?
No, but I figured it out. I just had
good. Okay.
a silly button pushed.
Yeah, you might have to scroll too, but hopefully it will follow. Like, can you see that I'm scrolling?
Yeah.
Okay, perfect. So first of all, you have to put that percent into decimal.
Okay.
Do you know what operation of translates to?
No.
It's always multiplying.
Okay.
Yeah, that has helped me big time when I'm trying to make sense of an equation in English and transferring it over to math. So I have 0.358, which is the same as 35.8%, multiplied by the mass of A2x. So I'm just going, yeah, so A2x, we don't know that mass. That's what we're trying to find out. This is the unknown we're trying to find out.
Okay.
What operation is?
I don't know.
That's okay. No, that's okay. Equals.
Okay.
Yeah. And then it's 55.1 grams of A. And once you have this equation, you can just solve it algebraically.
Okay.
So we're looking for, we want to get A2x mass all by itself. So what we want to do is bring 0.358 over to the other side. So we're going to solve this algebraically, because we know that 35.8% of the mass of A2x is going to equal 55.1 grams of A. So we're just going to rearrange this equation so that we can solve for A2x. And whenever we are rearranging the equation algebra, for instance, we want to take 0.358 and bring it over to the other side. So we look at what it's doing to our unknown, and it's multiplying. So if we want to get rid of it, we want to move it, we have to do the opposite of multiplying. Yes, so we're going to divide this side by 0.358. That gets rid of that, and that's going to leave us with A2x, its mass. Okay. And whatever we do to one side, we also have to do to the other side. So I'm going to take that 55.1 grams, if I can find my calculator. Oh, I just had it. Here it is. So 55.1 grams divided by 0.358 is equal to 153.91 grams altogether. And I can check that. I can say, and that's how much A2X we have altogether. And they're saying that 35.8% of this 153.91 grams is going to be A. So I can check that out. I can say 153.91 times 35.8%, which is 0.358. And if my calculation is right, I should get that 55.1 grams that I started with. So I'm going to try that. And I do get 55.1 grams, so that is correct. Now, if you didn't want to go through all of that, you would just remember that whenever you are finding the percent of an unknown where you know this endpoint, then you can kind of go right to this where you're dividing by the percentage instead of multiplying. Most of us are used to multiplying by the decimal to get the mass that they're looking for. But in this case, they're saying this is now our unknown instead of this, because probably up until grade 10, we're always looking for this answer over here. We never look at this one. We ever say, oh, find like 35% of 100 pancakes were eaten. So how many pancakes were eaten? We always find the end one, but now we're asking you to find the unknown variable is now part of is the multiplying part. See what I mean? Like it's a little bit, it's the same thing. It's just that instead of multiplying, we're going to be dividing.
I appreciate this because it was driving me crazy.
Yeah. And this is something that everybody has trouble with because we are so used to doing the same types of percentage problems over and over again where we're multiplying by the decimal. But you have to ask yourself, in this case, are we looking for the grand total or the part of the total? And if we're looking for the grand total, that's going to be this unknown here. If we're looking for part of the grand total, then this would have been the answer that we're getting. So either you're given the grand total or you're given the part, and you have to find the other out.
Thank you.
You're welcome. And I'm just going to have a shout out to Jeanette. I see you're here too. She's setting up Moana. That's my daughter's favorite movie right now. And Marianne, I'm going to write down. So I've got Emma, Katie, Jeanette, and Mary Ann tonight. Great. So we're just taking questions, and you can ask me anything that has to do with any type of question that you're doing in this unit, whether it's from the lab or from, Katie was just doing a question from the self-assessment, number 9 on page 190, and there's also questions at the back starting at page 197, I believe. Does anybody have another question for me?
Hi, Lori. It's Jeanette. I do.
Hi, Jeanette. Yes, go ahead.
After trying to get Moana on, my brain's a bit melted here. Number on page 199, number 69. I'm just struggling with the times 10, 3 with the first one.
No problem. So 199, number 69. There we go. And if you want, I can sing you every song from Moana.
You're welcome.
Yes, you're welcome. Exactly.
Oh, yeah, I know. Between that and Trolls.
Oh, yes, indeed. I do like the songs from Moana, though. I have to admit.
It was put together pretty good, yeah.
Yeah. Except that Google Play has all the songs plus all the songs that didn't make the movie. It's like an hour and a half. That's what's going through my house constantly and in the car.
I'll remember not to press the Google Play.
No, not good. So I'm looking at 69 now, and it says iron is found in Earth's crust as several different iron compounds. So iron is a pure element. It's Fe on our periodic table, and they're saying that it's found in the Earth's crust in several different iron compounds. So calculate the mass in kilograms of each compound that contains 1.0 times 10 to the 3 kilograms of iron. So I'm going to write that number down first. 1.0 times 10 to the power of 3, not 23, 3 kilograms of iron, which is Fe. And then the first one they give us is we have Fe2O3, and they're calling that compound hematite. So first of all, and what do they want? They want us to calculate the mass in kilograms, but we do molar mass in grams. So what we need to do is first calculate everything in grams, and then we will convert back to kilograms.
Okay.
Is that okay?
Yeah, I guess so.
Okay, yeah. She's telling me that's what we have to do, so that's what we have to do.
That's the way I gotta do it, I guess, and I have to.
So the first thing I want to do is I want to take that I have Calculate the mass in each compound. Oh, that contains, so each compound is going to have 1.0 times 10 to the 3 kilograms of Fe. I want to change that to grams so that I have it in grams. So 1.0 times 10 to the 3 kilograms. I'm going to move my decimal place over 1, 2, 3. So that means I actually have 1,000 kilograms of Fe. And then to change that to grams, I know I have 1,000 grams, in 1 kilogram. So that's actually going to give me 1, 2, 3, 1, 2, 3 grams. So 1 million grams of Fe. That's a lot, but that's what they're giving us. So if we have 1 million grams of Fe in this hematite compound, how much of the compound do we have altogether? So the first thing we need to know is what is the percentage of iron in hematite? And to do that, what we're going to do first is find out what the molar mass of hematite is, F2O3. We're going to figure that out. And we're going to find out the molar mass of iron in hematite. So it's the the molar mass of iron in the hematite. And there's 2 of those. And then we're going to find the percent composition from that percent composition of Fe in that hematite. And then we can use that to figure out how much hematite we have all together, very much like what Katie and I were doing before this slide. So it's a few steps. We've got 3 steps before we even look at doing the percent equation. So let's do these 3 steps first before we get too far down. And stop me as if you have any questions as we go through this. But the molar mass is pretty straightforward. We have 2 Fe and 3 oxygens. So our molar mass for this, and I'm just going to take this off just so I have room to do the molar mass. I need my periodic table.
19 for iron.
Oh, thank you.
Yeah, and I have 16 for oxygen. Yeah.
Perfect. So 2 times 19 and 3 times 16. There we go. And then all together, so 2 times 19 gives us 38 grams. And 3 times 16 gives us 48. Yep. So our molar mass altogether, 86? 86.
Yeah, that's Great. What I had. Okay.
Awesome. So that's the molar mass of hematite. Now we need to do the molar mass of just the iron alone, which we already have because that's right here, right? So molar, myself a little bit, mass of Fe2 is equal to 38 grams. And then we can do the percent composition of iron in hematite by, say, taking that 38 grams of iron divided by the molar mass of hematite all together.
So 38 divided to 86?
Yep.
So that's 44. 44%.
Yeah, 0.44 times 100, so 44%. There we go. So now we know that 44% of hematite is going to be the iron. So just like I did with Katie, I write that out because for me, I'm just able to say it in English better. So 44% of the mass of hematite, Fe2O3, is going to be the mass of iron, Fe.
Okay.
Now so now I can start changing this English sentence into a mathematic equation, because that's going to help me figure out what my mass, because what they want to know is what is this mass of hematite right here. This is our unknown. We just found out our 44%, and we know our mass of Fe, it's that 1 million grams, isn't it?
Mm-hmm.
So 1,000,000 grams. So in English, or sorry, in math, 44% becomes a decimal. That's that 0.44.
Mm-hmm.
And then Katie and I were talking about what of means in math. Do you know the operation for of?
Multiplication.
Yep, multiplication. We don't know the mass of Fe, so that's going to be our unknown. So mass of Fe, 203. And then we talked about that. That's going to be
equals.
Yep. And our mass of Fe is 1,230,000 grams. So now we're going to rearrange this formula so that we can solve for the mass of Fe2O3 in total. So we're going to divide both sides by 0.44 because dividing is the opposite of this multiplication.
Okay.
And that gets rid of it there. So instead of multiplying 1 million grams of Fe we're by our 0.44%, we're dividing by 0.44% because we're looking for this total mass.
Okay.
And
okay, that makes sense.
So that's going to be, so we're going to even have more because the iron is just part of that hematite compound. So I'm putting in 1 million grams, 1,000,000 grams divided by 0.44, and that gives me the grand number of 227.27 grams of hematite in total.
Okay.
But that's grams. We need to get it to kilograms, correct?
Correct.
So we're going to divide this by 1,000 grams, which means that we can just move this decimal place over to the left 3. 1, 2, 3. So we actually have 2,272.7 kilograms of hematite in total.
Hematite in total. Okay. And so we have to calculate the mass of each compound, though. So we got the total, yeah.
Yeah, and that is the mass of that hematite. That's that first one done.
Oh, never mind. Okay, yeah.
Yeah,
okay.
But it takes a lot of steps. We had to do the molar mass first of the hematite, and then we had to, from that, do the molar mass of the iron. And then that gives us the percent composition of iron. So we had to find out the percent composition of iron in the hematite in order to do this final step.
Now, when I look in the back, though, for the answer for 69A,
yes,
it says 1.4 times 10 to the 3 kilograms.
Oh, shucks.
And that's where I'm confused, I think.
1.43 times 10 to the
third. So you're keeping the 10 to the third there for the kilograms, but I'm not sure where you're getting the 1.4. Where you get that.
Yeah, where did that come up?
I'm hoping this won't be on the exam.
No, I don't think there's one this hard on the exam. There is percent composition, but what did I do wrong? Let me just check my FE. Oh, there it is. Oh, that might be it. FE isn't 19 grams. It's 55.85 grams.
Oh my gosh.
So,
I see you. I set you up. I'm sorry.
Oh, Janesh! No, I'm just kidding.
It's been a long
Do you know
day.
what?
I'm
so happy
sorry.
that that's what it is, because I'm like, I don't know what I did wrong. But let's just make sure that that's actually what it is.
Oh, I am so sorry.
No, it's no worries. It could have been a lot worse. Let's see. So that's that. Okay, plus 48.
I'm trying to flip my brain over. I just finished writing my biology exam today, so.
Oh, dear. Oh, so much work at the end, eh? So much work.
It is.
Okay, so.
Okay, now that we have the right number, sorry again.
Yes,
so
no, that's
55.
okay. 159.7. I'm going to make sure I did that right.
5.85, okay. Oh, that would make sense then.
That might help us.
Yeah, that
might. Plus 48, 159.7. Okay, so now we have, but the 38 grams is no, the 38 grams would not be correct, right?
Be correct, no.
No.
So that's 111 and 7.7.
So
that's what I get.
111 points. Oh, yes, of course. 111.7. Perfect. And then 111.7. So anyone who is tuning in, we just had the wrong molar mass for iron.
My bad.
Jeanette's going to take that.
I'll take the blame. I'll take the blame. I fully take the blame if I do something wrong.
So we're looking at 0.699 or 69.9%, so almost 70%. And that's what you got too, Jeanette, just so that we're the 69 point. Okay, so 69.9%. So that's going to change at this and this and that and that. Which is no big deal. 0.699. So 0.699. Oh, right. I'm going to save that out. I can't. Okay. So I'm going to do the 1, 2, 3, 4, 5, 6. 1 million grams divided by 0.699 equals.
Yeah.
Yay! Yeah.
Yay!
Yay!
I can see it now. I'll have to make sure I really check that I'm getting the right element on the periodic table for these.
Yes, that's all. I don't know where you got the 19.
Fluoride.
Fluoride, F. Yes, of course.
Instead of Fe. Yeah.
You know what? That is an honest mistake. And if you did something like that on the test, you just let me know. And if you, let's say that you did do that and you went back, it's like, oh, I see, I used the molar mass for fluorine instead of iron, but you did everything else right. Like that would be not, I would go back in and give you points for that. So, so don't let, like, everyone should go over their test after they do it and look at, and stuff like this, you can come back and just email me and say, can you please just have a look at this, and if, you know, there are any extra points you could give me, just, you know, have a look. So, but yeah, that's how you do that one.
Thank you for your patience.
You're welcome. You're welcome. And I see Mary Ann's got written, oh, with the discussion part of the lab, and I've been trying to finish it, but I honestly do not know what to write. How do I start? I just need to know how to get going. Mary Ann, thank you. That's a great question. So Mary Ann's doing her lab, and she's done her calculations. And so what you should have, if you envision this, Mary Ann, in front of you now, you'll have 5 different piles of your different compounds. Maybe you have a pile of sugar, a pile of salt, maybe you've measured out some vinegar, so you won't have a pile. You'll have vinegar in a cup. You'll have 5 different piles of your substances which represent a mole. In the discussion part, you want to answer your hypothesis. So looking back at your hypothesis, what was your hypothesis? Some some people would probably look at the idea of even though you have 1 mole of these common substances, some are going to have more substance than others. That idea that just because you have the same quantity of something, you're not going to have the same mass. So if that was your hypothesis, that that I am not going to have equal amounts of compounds in front of me, even though I have 1 mole of each substance, then in your discussion you're either going to agree or disagree. And you probably already realize now that you should probably you should have different masses of each substance in front of you, or different volumes, to show that even though you have a mole of each substance, because they're each going to have different molar mass, you're going to have more or less. So it's the idea of if you have a dozen mice and a dozen elephants, your masses are going to be different. So in the discussion you want to right away make a statement about that fact, that even though you have the same quantity of each, we have a mole of each of the compounds, that there should be different masses. You want to account for any human error in the procedure or in the lab. So thinking about how you're measuring out your substance, like, are you using the right tool to measure out mass? Because we're all in kitchens, most of us don't have scales, so you might have had to use a tablespoon instead. So you want to talk about how that can change your results a little bit. And then back to, so everybody should have that source of error. Explain a source of error for the lab. But back to that first thing of whether your hypothesis agrees or disagrees, that would be your beginning statement for your discussion. And then the paragraph that's included with that is just talking a little bit about the chemistry behind the idea of mole as a quantity versus mass. And then if you finish off with sources of error, I believe that's all you need. But I just want to check my rubric for a second. Marianne, does that help a little bit with your discussion? Your discussion is your conclusion, of course, and it's your last part of the lab for sure. And I'm just going to look on the news feed. I put in a rubric for the mole lab, so I'm just going to look for that, and I'll bring that up. Whoops. There we go. There's a marking scheme. So in that marking scheme, it says that in the discussion there are 5 points. Observations of 1 mole of each substance and how molar mass relates to quantity. So that's what I was talking about in terms of the mole versus mass and any differences that you see in your in the samples of your compounds. Hopefully moles and mass are going to be very different in your mind looking at that. Does this agree or disagree with your hypothesis? You want to do your sources of error, and you want to make sure that that is in paragraph form. And there's your 5 points. So 2 points in terms of explaining mole versus molar mass, 1 point for saying whether it agrees with your hypothesis or not, 1 point for your sources of error, which can usually be around your measurement tool. So, you know, is tablespoons the best measure for this type of observation experiment? And then make sure that your writing format is in paragraph form with good spelling and good grammar. So, in other words, use punctuation. Awesome, Marianne. I'm glad that, thank you for that question, because I'm sure everybody has, there's lots of people wondering the same thing. And if you go to the news feed, that marking scheme was posted on April the 2nd, so you can open that up and see what's needed for the conclusion there as well. And I see Jacqueline's joined us too, and she's writing a message. No problem, Jacqueline. Jacqueline sent me her calculations to see if she was on the right track, so I was able to give her, to tell her whether she was or not. So if anybody wishes to do the same, just send me an email with your calculations, and I'm happy to look at that. Or if you want me to look at a draft version of your hypothesis, I can do that as well. So that's all like front work that you're doing that I'm happy to help you with. So you're welcome, Jacqueline. We're just going over questions from the lab, questions from the self-assessment in the textbook on page 190, looking at review questions at the back of the book. Basically, any questions that you have that have come up in this unit, you can ask tonight. And Jacqueline, you don't have to respond back to me now in an email. And I see Marianne's left. She's probably gone to do her discussion now. So if anybody feels like they need to go, please don't feel like you have to hang around. You're welcome, Jacqueline. So any new questions?
Hi, Lori, it's Katie again.
Perfect. Hi, Katie.
Hi, I'm still working on my substances for my lab. I have the
yes.
5 that I chose. I'm nervous though that they're not going to be like the right idea of what you're looking for
Sure.
the lab.
Tell me what 5 you have.
I just sugar,
Yep.
cornstarch,
Ooh, yes.
salt, baking soda, and cream of tartar.
Awesome. So the only ones that I don't know the chemical formula for cream of tartar, or what was your other one?
Cornstarch?
Cornstarch. Because they're probably mixtures, right? Like homogeneous mixtures.
I did a lot of the math already. The cornstarch is C27H48O20.
Oh, and that's all that's in it?
That's it.
Oh, okay, perfect.
I've been Googling like all heck.
Oh, yeah.
The cream of tartar is just KC4H5O6.
Okay, no, I didn't realize they were pure compounds, because like vinegar isn't a pure compound; it's acetic acid in water.
Yeah.
So a lot of people are, which would be a great example of a source of error. So we're calculating really the molar mass of acetic acid without the water. So
Yeah.
you're going to have, it's not going to be exactly the same amount, but that's okay. So for you're fine because you're dealing with a pure compound.
Okay.
But for other students, for instance, someone is thinking about doing garlic powder, and I think garlic powder is a heterogeneous mixture of probably, well, sometimes it's dried garlic and salt, or some other like yeah, it's not pure of something. But if you want to take the most abundant compound in that mixture or the active ingredient, that's fine with me. Just I would mention that in the sources of error.
Okay, like the garlic powder, when I looked it up, it was C12H21NO4S3.
Oh, okay.
Yeah.
Does not sound natural at all.
No.
But it might be. Maybe that's what garlic, like a cell of garlic, that's what it's mostly made up of.
I'm not sure. My hubby pointed it out. He's like, maybe you should look into this. Yep.
Yeah.
Okay.
No, that's
Thank
great.
you.
You're welcome. I didn't realize that was you. See, that's the other thing. When I get it's one of the hardest parts for me is that I don't register names. I register faces, and sometimes I forget like who asked me that.
It's okay. I don't mind.
So sorry.
It's all right. I was just rifling through my spice cabinet going, okay, what have I got to use
yeah. What's this now? Meat tenderizer. Woo. See.
I don't want to read anymore now, though.
No. You've got two good ones, and they're pure compounds. So just go with those.
Perfect. Thank you.
You're welcome. And if people could stay away from gases, because those are hard to measure. I know when we do these kitchen labs, pictures are needed for these, so just pictures of your substances. If you choose a gas, it's kind of hard to measure that, and it's easy to do the math for it, so you know how many grams, but if you were to actually try and get a pile of that, it would be difficult. So try and stick with substances that you can actually like work with for sure. I think I had someone measure Comet at once and did that, and again it was more of trying to pick an ingredient that was the most abundant in it. I think they had to go to some weird website to find out the percentage composition of the different compounds that make up Comet. So that one can be a tricky one. A non-tricky one is borax, because borax cleaning detergent in a powder form, that's all pure elemental boron. So that one's a nice one to do as well, if you have borax in your home.
I do.
There you go. I do too, but I live in the country and my water's awful, so anything to get anything whiter, I have.
I mix it sometimes with icing sugar and put it around the house for ants as well.
Yeah. Oh, borax you can use in so many different ways.
Yeah.
It's great. There's a lot, and because it's a naturally occurring chemical, there's no artificial fragrances in it. You can use it in your dishwasher as a descaler and as like a dishwasher cleaner. You can use it in your laundry for ants.
It's versatile.
Yeah.
Definitely.
And cheap. I find it's not very expensive.
No, it's not.
Yeah.
Okay, yeah, I'm looking. I'll be honest with you, I haven't even started the lab. That's what I'm trying to do for tomorrow, so.
Oh, yes. Now that, I know I wrote today that if everybody could get it in for me by the end of this week, that would be fantastic, just so that I have the weekend to mark it, because that turnaround from winter to spring is really short. But if you can't because you're working on the test, that I totally understand that. It'd just be nice if I had like half of them in, just so I could get started. That's all. So don't feel pressure like, oh.
Oh no, I'm gonna get it done before, like, I think it's Friday was the due date.
Yes.
Friday there. Yeah. No, I'll get it done because I have other stuff I have to get done as well for the other course. So, and then my test is for the chemistry is on Tuesday. So,
Excellent.
It's cram time.
I know. Oh.
But, this is what I'll be working on tomorrow. So maybe if I have any questions for you, then I'll maybe send you an email or something.
Most definitely. And I am around this weekend, so feel free. I know. Don't worry that it's a long weekend. If you guys have questions, just send me an email, and I'll be happy to answer. That's no problem. Not going anywhere interesting.
I'm going to Cape Breton. I'm taking the kids to Cape Breton to my parents, and they live right on the ocean. So I'll have a nice view when I'm studying.
Oh, good. And babysitters, which would be great.
And babysitters, yes.
Yeah.
Yeah. Okay, well, thank you so much. I think I'll call it a night here and get my butt in gear here. So
Great. Okay, no problem, Jeanette. Have a great long weekend, and for sure we'll chat if you have any questions. Okay.
That's great. Thanks so much. Good night, everyone.
Good night.
Lori, I think I have the opposite problem. I spent too much time, not spent too much time doing my assignment, but I focused all of my energy into doing the lab, and I have not studied enough for the test. And I write on Thursday, and I've been working I work 12-hour shifts Monday today and tomorrow, and now I'm kind of in panic mode.
Could you change it? Get it changed till Tuesday or Wednesday?
I would love to do I'm off Tuesday, but I work, unfortunately, I work all this week, early this week, and I'm back on Friday, Saturday, Sunday, Monday. And Tuesday's my day off, but I write my chemistry and my math on Tuesday also.
Oh, so you write your chem test on Tuesday?
Sorry, my bio and math.
Oh, your bio and math. What about Wednesday? Oh.
I work.
And then you work. You know what, though? You have done all of the calculations that you have done on your mole lab are pretty much like 85% of the test. The only thing that you haven't covered is percent composition, which is what we were going over tonight, and then changing empirical formula over to molecular formula, and there's a video for that. But that's the only two things that you're missing, whereas like 85-90% of the test is all the mole stuff. I think you'll be fine, Jacqueline.
Okay.
Have you worked on the mole the pre-test?
Not a whole lot. I honestly have not had any time for these 3 courses, and working in the 2 kids is not working out for me.
No, in the last part, and also just it's the last panic, right?
Yeah.
Yeah. Well, just, you know what, it sounds like you can't change anything around with the test because you're booked solid. So keep your Thursday test, and leave you're done your lab though.
Yeah.
Yeah.
I have some tweaking, but yeah.
Do you know what? Don't tweak until Wednesday. Put that aside now. Put the lab aside, because you only have tweaking, and you can get back to it on Wednesday. And as long as you hand it in to me on Wednesday, you'll be fine. Or you could do the test next Thursday.
It's next Thursday.
The 20th.
I'm just gonna grab my little day planner.
Yes.
The 21st?
The 20th, the Thursday.
No go. I work. So I work Friday, Saturday, Sunday, Monday. I'm off the 18th. I work the 19th, 20th, off the 21st.
21st in the morning.
21st in the morning. I'll call NSCC Akerley tomorrow at work and see if they can.
See if they can do that. I don't know if they can, but I haven't had anybody say that they're not open those days. I just have to have the marks in by that afternoon, so I would be waiting to see how you did, and then I just have to put your but that would be the only thing left I'd have for you would be that mark. So, and D2L calculates it, so it would be, I'd have enough time to get my marks in if you were able to write in the morning.
You know what? I have appointment time at work that I could probably take a morning off to do.
Okay.
Or an afternoon.
It would be more of just I have no problem with you doing Wednesday, Thursday, or Friday morning. So if you're able to, through work and through, did you say Waterfront or Akerley?
I work right across from the Waterfront, but I guess I could do it at Waterfront because it's right across from the hospital. But usually, if I come from home on my day off, I would go to Akerley because it's closer to me. But.
Well, just check both testing centers and see if they have what their availability is for that Wednesday, Thursday, Friday, and then check with work, and then just let me know what you could figure out. That would be the best because that would give you your week. And get your bio and your math completed.
Yeah, because it's oof.
Yes.
It's heavy.
Yeah, and your work schedule is heavy too.
It's just this 2 weeks. I work 12-hour shifts, so I don't have to work as frequent as other people do. But
yeah.
It's this weekend, on the weekends. I only work 1 weekend a month, and they're 8-hour days. So then I end up having like really kind of long 2 week and a half kind of stretch, and it just happens to be landing on my lap during this.
Yes.
But
Well, call them in the morning. First, call Akeley and Waterfront and see what their availability is, and then just let me know what you decided. If worse comes to worse and you have to write it on Thursday, I think you'll be able to do it.
okay.
Yeah.
Okay. Yeah, because I don't need to write until noon on Thursday, so maybe I'll just go in to the testing center and no, I'll study at home. I'll have the kids at daycare at school.
Yes.
Yes.
Okay.
Last time I went to the testing center to study early, and it was a complete fail. It was so busy I couldn't focus. My ADD was running. I was chasing butterflies. There was too much going on.
Yes. No, it won't be quiet. I was going to say next week it might be quiet, but it probably won't be quiet on Thursday.
Yeah, I think maybe
Okay.
I'll just stick with the schedule.
Okay.
And
Well, I'm around, so do you work tomorrow, Jacqueline?
I do 7 to 7.
7 to 7. Well, and then you're working on this stuff right now. So you have tomorrow, you'll have a little bit of time tomorrow night to study, and then Thursday morning. My suggestion is to go right on to that mole pretest and look at the questions that they have there and see how many of those you can do, and that will be a great indication of how much you know. And I think you know a lot just based on the mole lab that you did.
Okay.
Yeah.
I'm really comfortable with the stuff that I did in the lab. I did initially I did it wrong, and I caught myself. I was just a little bit, actually I was completely done, to be truthful, but some of them I had done right, and some of them I didn't. I was multiplying instead of dividing, and I was like, why are these numbers really big and these ones really small?
Right.
And I caught myself. That's
Yes.
why I had sent you the draft, just because I was like, oh man,
Yes.
I'm really second guessing myself now.
Yes, and that's what happens with this lab for sure. So that's why I always say that students should get the mole lab done before they do the test, because you learn a lot by working with these substances and seeing how, even though you have 1 mole of each substance, they're different volumes, they're different masses, because the size of the atoms are different.
Right.
So it's great, because that really solidifies this really abstract concept of 6.02 times 10 to the 23. Like, it's too hard to comprehend, but doing the lab, it kind of can solidify things a little bit better.
I agree.
Well, good luck. If you have questions, just email me, and I'll be around tomorrow night. So if you're working late, just let me know if you have a question, and I can give you a hand.
Okay, great. Thanks so
Okay.
much.
Good luck.
Thank you. Have a good night.
welcome. You
Have a
too.
good Easter.
Yes. Have a good long weekend. Woohoo!
Yeah.
Oh,
Okay.
you're working though, but
I am.
you are.
It'll still be good. It'll still be good.
It'll be good. It'll be good. Okay.
Yeah.
Okay.
The patients are lovely.
There, and yes, and they'll appreciate you.
Yes.
Yes.
Yeah.
Yeah. Okay. Good night.
Thanks. Good night.
You're welcome. Katie, Emma, do you have any questions left?
I have one.
Yes, go ahead, Katie. You have great questions.
I'm working on my lab, and I
great.
got to the point where I'm supposed to calculate how many molecules it takes to fill 1 tablespoon of the substance.
Mm-hmm.
So it's molecules in 1 tablespoon equals number of molecules over the number of tablespoons. And I hope I'm doing this right, and I don't feel like I'm doing it right.
Sure. So you have 1 tablespoon of substance, and you need to know the number of molecules in that substance. So you have 15 grams if you have 1 tablespoon, right?
Yeah.
Of molecules. First of all, you need to take what your mole, the mass of 1 mole.
Mm-hmm.
Of that substance. So the molar mass of the substance.
Okay.
And take your 15 grams and divide it by that molar mass, because that's going to give you the percent of compound that you have, because that 15 grams might not be exactly 1 mole, right?
Yeah, because like my first one for sugar, because I'm sure I'm not the only one who did sugar, it turned into 1.00777 moles.
Yes. So what's your molar mass for sugar? Do you have that there?
My molar mass for sugar is 345 grams.
Yep, that sounds great. 345 grams, but you only have 15 grams of that. So normally what we would do is, we know that 1 mole is going to give us 6.02 times 10 to the 23 molecules, right?
Yes.
But we don't have 1 mole. We have this percentage. So we're going to take whatever this is and multiply it by 6.02 times 10 to the 23, and that will give us our number of molecules.
Are you writing that down? Because I can't see anything.
Oh, I am.
Okay, because I can't see it.
Can you see the whiteboard?
I can see the whiteboard, but there's nothing on it.
Oh. Do you have a scroll bar?
I do, and I'm scrolling and still not seeing anything. I did see it earlier, and there was like a little flash, and now it's all gone.
Here, just a sec. I'm going to see if I... I'm showing whiteboard 2.
I don't know. Presentation stopped.
Okay. Can you see it now?
I can see the whiteboard now. Yes, thank you.
But and my markings?
No, there's nothing.
Oh, there's nothing. Okay.
Oh wait, I found it.
Oh.
What the heck? Okay. All right. Okay, now I see where you wrote that. Okay. All right, that makes sense. So 15 grams divided by the 345 grams.
That's going to give you a decimal, and that's your percentage, like how many moles you have. So 15 divided by 345 means that you have 0.0435 moles. And then you multiply that by 6.02.
Okay. So I'm definitely doing something wrong. Uh-oh. Okay.
So because
I'm glad I asked you.
Yes.
Because this is very wrong then.
Because if you have 345 grams of sugar, that's going to be your molar mass. So 1 mole of your sugar is going to be 345 grams. And then you divide that by 15, so that's like 23 tablespoons of sugar.
Yeah.
To make 1 mole, but we only have 1 tablespoon of sugar.
Okay.
So that's why I have the 15 grams divided by 345 grams gives us this 0.0435 moles of sugar. So just a scant piece of that mole. And and we always multiply moles by the Avogadro's number to get our number of molecules. So 0.0435 times 6.02 times 10 to the 23. And that's going to give us 10 to the 23, but we're going to do 0.0435 times 6.02 equals 0.26187. I'm just going to say 0.262 times 10 to the 23 molecules.
Okay, I got the same number, but all I did was take Avogadro's number and divide it by the number of tablespoons.
Yeah, you could do that too.
Okay. Not
And
as wrong as I thought. I was just envisioning recycling all of this.
yeah, no, 6.02 divided by 15 is going to give us 1 tablespoon. And that gives me
Because I divided it by 23 because that's the amount of tablespoons I
oh,
would buy.
23. Yes, sorry.
Yeah.
That's
Yeah.
better. 6.02. I divided by 15. 23. Yes, and you get the same number as I do.
Okay.
You're fine. You're good. And then if you wanted to, this isn't in proper scientific notation, so I would move my decimal over 1, which means that I only have to have this go to 22.
Okay.
So you'd have 2.62 times 10 to the 22 molecules.
22. Perfect. Thank you so much, Laura.
Good for
I feel
you.
better now.
Oh yes, and you were doing it the right way too. That
Okay.
you could do it that way as well, for sure. Yeah, that's the easier way. Do that.
I'm trying to follow the lab. What I do wrong?
Yeah. No, you're good. You're good.
Okay. Well, thank you very much for tonight. I appreciate it.
You're welcome. You're welcome. And I see Beth's here. Hi, Beth. Don't worry.
Hello.
Hi. I've recorded everything, so if you need to go back and look, but I've got.
Definitely will, yeah.
Yes. I have, but I have time. Do you have questions?
No, I'm kind of just trying to soak in what I can. Yeah, like I've been picking away at this for a while now, so this one's probably the hardest. Not probably, definitely the hardest by far for me.
Yes.
Yeah, so
It's
I'm
probably
kind
the
of
hardest by far for many people because of
I don't
the.
even know what questions I have. That's how confused I am. So, but once I open my book and I look at my questions and I work through it, it's usually fine. So I mean,
Okay.
I just need to I need to go over the videos again, probably a few more times. I already
Have you
one
looked at the
in hopper.
pretest? Have you looked at the pretest yet?
I did. I think I got to like question 4, and I've been doing the same thing, just kind of coming in and out of it. But
Good.
is that basically what our test is going to be?
Yes.
all
Yes.
about?
Yeah.
Okay.
The pretests are always supposed to kind of mirror the tests,
Okay.
so that you see what the types of questions we're going to ask, and then you'll see them again on the test.
Perfect. So that's a relief because and we can't have our notes, hey?
No, it's just the textbook.
So I guess like when you did the videos, 3 videos, I pretty much just followed that as my outline, right? And I guess all of that's in the book. I'll just have to kind of match it up and see, what fits where, because I use that as my outline. Like I'll go through, it's asking me this. Where's my title? Convert grams to what? You know what I mean?
Yep.
Like,
That's
I'll just have to find a different system
And
put it
there's
in my book.
and there's great examples in the book. Like I would make sure that I understand the examples that they have,
Yeah.
and then you can bookmark the ones that you absolutely do need to kind of use as an example. That's what I would do. Like ones that I kind of am iffy on, I'd have a little tag to it so that I can get to it quickly.
Okay.
Yeah.
All right. Yeah.
When
So,
do you write your test?
I actually had it booked for the 13th, and then when I seen your post, I changed it to the 19th.
Oh, good.
So I had
Perfect.
extra time, yeah.
You have lots of time left, so no
Yeah, and
worries.
As
Yeah.
long as I keep looking at it every day, and it kind of sinks in a little bit more and a little bit more.
Yeah.
So, I did notice when you guys were doing that, like the number you used the 435 for the sugar.
Yes.
So you must have. I jumped right in the middle.
Oh
and
yeah. So
yeah.
do you mean this number here, the 345 grams here?
Yes, that's the one there. So that's the molar mass, right, of the compound of sucrose.
Yes.
So it's rounded up. Is that because we're supposed to round it?
You can. For this molar lab, if you wanted to round it to the nearest tenth, I'm not going to be particular about decimals for the lab.
Okay, because I probably won't, like, if I don't have to do that, I'll just leave it as the 342.34.
Yes.
Is that okay?
Yep.
And then I just do the math all the same?
Yep. Yep, and if you just show me your calculations, I'll be able to see where you got it from, and that's fine. That's great.
Yeah, okay, because I have everything written out here, and I'm actually getting everything into their little dishes. I got cute little ceramic dishes.
Good. And you can take just one picture of all 5 if you want, instead of taking like individual ones and trying to put them in.
Yeah.
Just a single picture is fine.
Sorry, I have a big sheet of paper, and I'm just kind of labeling them, and they're just tiny little dishes, so I think they'll all fit on there. Cool.
Yeah. Mind you, 23 tablespoons is what Katie was saying was is how many is 1 mole of sugar. So I don't.
Oh, wow.
Yeah, sugar is huge because it's such a big C6H12O6. I think that's the formula. So it's a lot of atoms in there.
What was the formula that you just said?
C6H12O6 for glucose. I think a lot of people use glucose instead of sucrose for table sugar. I take both.
But it's so weird that the numbers are so close. So she must have got 345 bang on, did she?
I don't know.
Did she round it? Oh, you don't know?
We did,
okay.
Yeah, she just gave me that one. She might have rounded it. It's
okay.
Yeah.
Because I'm actually using C12H22O11.
Yes, and that works well too.
Okay. It's funny they're so close.
Well, C6 H12O6, and you're using C12
H22O11.
O11. Yeah. Well, sucrose and glucose, they are very, very, they're very similar compound, like organically. So it's so interesting. Yeah, there must be some.
It is. This is a very interesting course. Like, I had no idea. I was terrified walking into this, and it's turned out to be actually really cool. So
it's I agree. I hated chemistry in high school. I didn't understand any of it. It just made no sense. And as an adult, it just, like you said, it's so interesting. Like, I think it's because I know more about nutrition, and I'm able to make connections to chemistry. I think there's just more connections out there because we've experienced more than in high school when we're not really.
Yeah, totally. Like, we have a bit of an understanding of the world around us, so it's
exactly
seeing it plugged in everywhere. Like, it's neat. We were looking for vitamins the other day, and I'm like, hey, there's some elements. That's awesome. Yeah. Oh, that's funny.
I know. It makes you feel really smart too, eh? Like, I know what they're talking about. Yeah.
I have those moments.
Yeah. Well, it was like that. I saw the video that I posted on the cilantro. I'm like, look at the chemical terms they're talking about. This is great. Aldehydes. Like, who would understand what an aldehyde is except for, our Chem1046 group, because they're dealing with organic compounds and, the aldehydes and and here we have it with cilantro. So I love that when you can start seeing, like, understanding more because you have this background now.
Yeah, that's it exactly right. It is pretty cool. So I will let you go. I totally snuck in here at the end.
Yeah.
I don't know what's happened this last little while. It's just been chaos around my house. So yeah. So anyway,
and now we're gonna put chocolate in the mix.
You know what? The last 2 years, I had to throw away like 2 Sobeys bags, like one for each year. He doesn't eat any of it. So this year, it's nothing. No, I might get him a bunny, just, but yeah, it's all little toys and little outside things and weird toys. And
nice. And with spring,
totally,
yeah. And hopefully this weather will stick. Yeah. Oh, that's good.
I'm hoping.
You got to save a little bit for Mom, though, eh? A little bit, a little stash.
Yeah. Break the ear off and put it away.
Yes, exactly.
Oh.
Well, good luck with your lab, and if you have any questions, some students have been just emailing me their calculations just so that I can have a look and see if they're on the right track. So if you want to do that, feel free.
Wonderful. That is fantastic, because I was kind of stressing out, like, how am I going to know if it's right or not?
Yes.
So I will probably take advantage of that.
Yeah, and then I'll just take a look and see, and then let you know if there's anything that you need to review. And also, just if you have any questions leading up to your test on Wednesday, just let me know.
Okay, perfect. Thank you so much.
You're welcome, and have a great weekend.
You too. Happy Easter.
Thank you. Happy Easter. Bye,
Okay.
Beth.
Bye-bye.
Bye.